In this video, we're going to talk about how to solve some questions involving logarithm. That is, solving equations involving logarithm. I refer you to some of my videos I made on theory of logarithms and the probably changing of base of logarithm. It's actually pertinent to understand those basic concepts of theory of logarithm because those concepts actually will be needed in solving any equations involving logarithm. Let's take a look at the first question we have to solve it. Here is 2 log x base 9 minus 6 log x base 9 equal to 2. How do we get this kind of question solved? Remember, when you're solving any equations, be it linear equations, quadratic equations, or logarithmic equations, the purpose is to get value for the unknown. And the unknown we have here is actually x. So how do we get the value for x here? This is the first step we can do when we have this kind of question here. Checking here, we have 2 as the coefficient of log x base 9, and here is 6 as the coefficient of log x base 9, and at the same time we have 2 as a result. So we can actually divide 2 by 2 because 2 is a factor of all the terms we have as the coefficient and even the result of the equation. So dividing through by 2, we can get to have 2 log x base 9 divided by 2 minus 6 log x base 9 divided by 2 equal to 2 over 2. And then we can get rid of this. So that means we're left with log x base 9 minus, and then this is actually going to be 2 here, 1, 2 here, 3. And so this becomes 3 log x base 9 is actually equal to 1. And then if you look at the 2 terms we have there, we have base 9 here. So they actually have the same base. So we can take common logarithm to base 9 of the 2 terms we have there. And that will entails us to actually use one of the laws of logarithm. And then therefore, if it is subtraction, taking here. So this becomes log x base 9 minus log x cube base 9 equal to 1. And then we can take common logarithm to base 9 of the 2 terms we have here. And then this becomes the log to base 9. And then remember, if it is subtraction, taking common logarithm is going to change to division. So we have x divided by x cubed here equal to 1. And in this case, we can actually, since this one is x and this one is x cubed, this is the same thing as x raised to the power of 1. And then in this case, we can just write x raised to the power of 1 minus 3. Remember, if it is division, one of the laws of indices says we're to subtract the powers in as much as they have the same base. And therefore, log to base 9 of x raised to the power of 1 minus 3 equal to 1. And then we end up having log x raised to the power of minus 2 base 9 equal to 1. And then one of the things we can do is to change this, okay, to index form. Okay, I refer you back to one of my videos I made on the relationship between indices and logarithm. Okay, so some kinds of fundamental understanding is required then. So changing this one to index form, we have 9 raised to the power of 1 equal to whatever terms you have it. So in this case, we have x raised to the power of minus 2 equal to 9 raised to the power of 1. And then in this case, we have x raised to the power of minus 2. In order to get rid of this minus 2 here, we have to multiply the powers of both sides by the reciprocal of minus 2 here. This is taken as minus 2 over 1. This is going to be minus 1 over 2 equal to 9 raised to the power of 1 times minus 1 over 2. And then this can get rid of this, and minus times minus can be positive. So we're left with ordinary x here equal to 9 raised to the power of minus 1 over 2. And then to apply one of the laws of indices, we have this minus is becoming 1 over 9 raised to the power of 1 over 2. And of course, this is becoming 1 over 9 raised to the power 1 over 2 becomes plus or minus square root of 9. And then finally, we do have x equal to plus or minus 1 over 3 because the square root of 9 is actually 3. Let's take a look at another question. Here is log 4x plus 3 base 10 minus log x base 10 equal to 1. Okay, so in this case, we need to apply one of the laws of indices. Taking common logarithm to base 10 of the two terms we have there, this becomes log to base 10. Remember, if it is subtraction, it has to be changed to division when you take common logarithm of whatever base we have. This becomes 4x plus 3 everything over x equal to 1. And then we need to change this to index form. Remember, the base here is 10 raised to the power of 1 is equal to whatever the term we have there. So that's how to change from log form to index form. And therefore, this one becomes 4x plus 3 over x equal to the 10 raised to the power of 1. And then it's also the same thing as writing 4x plus 3 over x, which is equal to 10, because 10 raised to the power 1 is 10, but 10 over 1 this time around. We can just do cross multiplication so that we can obtain the value for x. Therefore, this one becomes 10x, that's 10 times x, equal to 4x plus 3. And of course, we need to move this to the other side of equality sign, and that becomes 10x minus 4x equal to 3. And then this is 6x equal to 3, dividing both sides by 6. This becomes x equal to 3 over 6. And finally, our x can be 1 over 2. So that's how to obtain the value for x in such log equation. If 5 log 81 raised to the power of minus 1 base x here equal to minus 20. How do we solve for the value of x in this kind of log equation? What we need to do first is to apply one of the laws of logarithm here. We need to move this one to the back here to make it have a coefficient of whatever term we have. And therefore, this one becomes 5 times minus 1. And then log 81 to base x equal to minus 20. And therefore, 5 times minus 1 is minus 5. Log 81 base x equal to minus 20. And of course, minus 5 has become the coefficient of log 81 base x. So we need to divide both sides by minus 5. And therefore, this becomes minus 5 divided by minus 5. This gets rid of this. And therefore, your log 81 base x equal to 4. That is 20 divided by 5, which is 4. And then we've gotten to a point where we need to change the log form of equation we have to an index form. And then what we do here is x, which is the base of the log, raised to the power of 4 here, equal to the number, which is 81. And so in this case, we have x raised to the power of 4 equal to 81. And then having this concept, we can actually have it as x raised to the power of 4. 81 can be written as 3 raised to the power of 4. And then in this case, we have an exponential equation in our hands here. So we can basically equate the two exponential equations we have there. Equating this to this, because they have the same powers, and therefore the basis two will be equal. So equating the indices, our x is actually going to be 3. And that is the answer to the value of x in that question. Let's take a look at another example. Here is log. We actually have log 3x plus 1 base 10 minus log 2x plus 5 base 10 equal to 0. This question pretty looks like one of the examples we have solved previously. Okay, one of the things we will want to first of all do here is to take common logarithm of the two terms we have there. And remember, if it is subtraction, taking common logarithm will change the sign to division. And therefore, here is log to base 10 in the bracket 3x plus 1 over 2x plus 5. Okay, equal to 0 here. And then the next thing is to change this log form of equation to index form. Remember, changing this to index form, the base has to be raised to the power of whatever you have there, equal to whatever number we have there. And therefore, here is 3x plus 1 over 2x plus 5 equal to 10 raised to the power of 0. 10 raised to the power of 0 this way. And therefore, here is 3x plus 1 over 2x plus 5 equal to 1, because whatever raised to the power of 0 is 1. And then we just want to go ahead and do cross multiplication. So doing cross multiplication here, 1 times everything we have here is equal to 3x plus 1. So we can just write it as 3x plus 1 equal to 1 times everything. The term remains the same. and therefore we need to collect like terms. Moving 2 to the other side of equality sign, that becomes 3x minus 2x equal to, we still have 5 left there, and then this is plus 1 to the other side, that becomes minus 1. So 3 minus 2 is going to be 1, which is x, okay, equal to 4. So obtaining 4 for the value of x is the correct answer to solving that log equation. Log 2x plus 1 base 10 minus log 3x minus 2 base 10 equal to 1. And then this is pretty easy. Solving this kind of question, we need to apply one of the laws of indices, taking common logarithm, one of the laws of logarithm, taking common logarithm to base 10 of the two terms. So taking common logarithm, we have log to base 10. This is 2x plus 1 over 3x minus 2 equal to 1. And in this case, changing this to index form, this becomes 10 raised to the power of 1. And it's equal to whatever terms we have there. So this becomes 2x plus 1 over 3x minus 2 equal to 10 raised to the power of 1. And of course, here is 2x plus 1 over 3x minus 2 equal to 10 raised to the power of 1 is 10. And of course, it's 10 over 1. So we can do cross multiplication. Doing cross multiplication, that gives us 10 bracket 3x minus 2 equal to 2x plus 1. And then we use this 10 to open up the bracket there. We have 30x minus 20 equal to 2x plus 1. And then by the time you collect like terms, we have 30x minus 2x equal to 1 plus 20. And then here is 30 minus 2. That's going to give us 28x equal to 21. And then we can just choose to divide both sides by whatever we have as the coefficient of x. So this gives us x equal to 21 over 28. And then we have to reduce that to its simplest form. Remember, answers in mathematics are always expressed in its simplest form. And therefore, using 7 as a common factor to reduce that, that gives us 3 over 4. That is 7 here, 3, 7 here, 4. So our answer is 3 over 4 to that log equation. Let's take a look at another example. Here is 4 log 216 base x equal to 12. Okay, 4 log 216 base x equal to 12. One thing we need to first observe is this is the coefficient is a factor of whatever we have here. So we can just get rid of that coefficient by dividing both sides by 4. So here is 4 log 216 base x equal to 12. Dividing both sides by 4, we actually get rid of this. And this becomes log 216 base x equal to 3. And then we need to change this to index form. Changing this to index form becomes x raised to the power of 3. As x raised to the power of 3 equal to 216. And then solving for x here. And of course, once you have a power here, it becomes the root on the other side of the equality sign. So here is cube here. That becomes cube root here. So it's cube root of 216. And our answer is meant to be 6. So that is the answer to such a log equation. Thanks for watching. Kindly subscribe to my YouTube channels.